We're just going to continue with the idea of replace and reduce. Yesterday we did main identities. Okay, those twins that can swap places and still keep it identical. So we had the main identities, then we had the reflection identities. And what was the third group? Shift. All right, so those were the three that we did yesterday, and then we're only going to do one set today, but there's several that fall in this category, identities. All right, so that was yesterday. All right, now we're going to move on to something called Pythagorean identities in trig. All right, so remind me about the Pythagorean theorem. How does that go? All right, is it okay if I write it this way? C squared equals A squared plus B squared. Is that going to throw you off? It's the same thing. All right, C is by itself, or at least on the side by itself. How would you rearrange that so that A would be by itself? Okay, so A squared by itself would be C squared minus B squared. How would you rearrange that to have B squared be by itself?
A squared minus B squared.
Okay. Okay, wait, B squared by itself. Maybe look back at the first one. How would you get B squared by itself? It'd be C squared minus A squared is how you would get B by itself. You need to be able to be comfortable knowing how to do that, how to move things around so that you have different letters by themselves. That was with the Pythagorean theorem. Now we need to do it with the Pythagorean identity. Okay? So this was different versions, all right, different variations on the Pythagorean theorem. Okay, so now we need to switch to Pythagorean identity, which means it's going to have some trig things in it. The main form of the Pythagorean identity uses sine squared and cosine squared. All right, it goes like this. Where A squared is, that's sine. And where B squared is, that's the cosine part. And so this is what it would look like. So let's kind of look at the normal Pythagorean theorem. I'm going to write it in this normal order. A squared plus B squared equals C squared. You don't have to necessarily write that, but where A is, that's going to be sine. Where B is, that's going to be cosine. And so it's sine squared, but it's a sin to leave it without a variable. So we need a variable there. And so we're going to, x is fine, you could use any variable, but it comes after the square. And then where b is, we're going to put cosine. So we'll put cosine squared. But again, you don't want to leave it without a variable, so we'll put an x after that. And where c is, we're actually going to put the number 1. This is an identity or identical. These two sides are identical in trig. With 1 squared, do I really need the square on a 1? What is 1 squared? Yeah, so I'm just going to write it like that. All right, that is the biggest form, that is the main form of the Pythagorean identity. Sine squared plus cosine squared is always replaced with the number 1. That's the big main one. Okay, that one you got to memorize. But you should also be able to manipulate it, which means if I say, okay, what would you do to get sine squared by itself? So tell me, what would you do to get sine squared by itself?
1 minus cosine.
So sine squared by itself, with an x, would be you subtract the cosine to the other side. So 1 minus cosine squared x. Those two things are identical as well. You can replace in order to reduce using those. And then if you look back to the original form again, Okay, what would you do to get cosine squared by itself? We do the same thing, you use subtraction. And so cosine squared by itself is equal to 1 minus sine squared. So these are variations. Okay, I'm not changing anything, I'm not changing the truth of those things. I'm just putting them in a different order. Sine squared plus cosine squared has the identity of being equal to 1. And because it has the identity of being equal to 1, then I can move all of that around. I mean, it's very much like doing like regular addition. If you said 2 plus 3 equals 5, that's an identical truth. We know that to be true in math. If I say get 2 by itself, well then 2 will be equal to 5 minus 3. I'm still using all the same numbers, they're just in a different order. Or get 3 by itself, well 3 is equal to 5 minus 2. Those are all true statements. They're just written in a different order. The same thing is true when you're learning about the Pythagorean identity. All right, so this set right here, this version and the 3 variations, you need to commit to memory. Now, if there's a version for sine and cosine, there's also going to be a version for the other pairs, okay, the other sets. So sine and cosine create a set, and then there's going to be a set for tangent and secant, and there's going to be a set for cotangent and cosecant. Okay, so let me show you the other sets. We don't really need any other stuff. Okay, let's start fresh. Okay, let's start with the basic one. Sine squared x, after it, cos squared x, always is equal to the number 1. Okay, other than using subtraction to move things around, we can use division to move things around. And the division we want is to divide by cosine squared. That means put cosine squared as a common denominator to everything. So what would that do to the problem? So sine squared of x with cosine squared as its denominator, plus cosine squared of x with cosine as its denominator, so common denominator, equals 1 with cosine squared as its common denominator. That's legal in math. It's legal if you do the same thing to everything, give it all a common denominator. So now let's reduce. What does sine squared of x over cosine squared of x reduce to? Well, what does sine and cosine reduce to, just the two of them? Tan. And that's true here with a square and an x as well. So those things reduce to tan. Plus, all right, what does cosine squared of x over cosine squared of x reduce to? 1. And then 1 over cosine squared, what does that get replaced with or reduced with? Well, I know what 1 over cosine is, or we should from our main identities yesterday. What's 1 over cosine? Secant. So what do you think 1 over cosine squared is? Secant squared. And this now results in the second Pythagorean identity. So this is Pythagorean identity number 2. So Pythagorean identity number 1 was this one right here, with its variations. Pythagorean identity number 2 is this one that uses tangent and secant and the number 1, and it has variations also. You can make variations on that by using subtraction. So I can subtract 1 to get tan squared by itself. So that would be secant squared x minus 1. Or I could subtract tangent squared to get 1 by itself, and that would be secant squared x minus tan squared x. So these are variations on the same Pythagorean identity. There's so far there's 2 Pythagorean identities, and each of them have 2 variations. So if we created this second Pythagorean identity by using a common denominator of cosine squared, how do you think we're going to create the third Pythagorean identity? Yeah, common denominator of sine squared. All right, so let's put a box around this one because this is the second set of Pythagorean identity. And we're going to start over a third time. We're going to start over with sine squared x plus cosine squared x equals 1. And this time, we're going to get a common denominator of sine squared. So common denominator sine squared, common denominator sine squared, common denominator sine squared. And then we'll reduce each of these. So the first common denominator of sine squared means it reduces to the number 1, plus, because sine squared over sine squared x is 1. And then we have cosine squared x over sine squared x. Well, we already know that cosine over sine reduces to what trig expression? Cotangent, right? So with the squared, this would be cotangent squared of x. And then 1 over sine is replaced with cosecant. And so this, since it has a squared on it, would be cosecant. And this is Pythagorean identity number 3. And it also has 2 variations. So you've got your 3 different Pythagorean identities. Each of those Pythagorean identities has 2 variations on its own. So let's use that same pattern that we had before. What would I do to this third equation? How would I get cotangent by itself? Subtract 1. All right, so let's do that. So cotangent squared by, cotangent squared by itself would be cosecant squared x minus 1. So that's a variation. The truth is still the same. We're just rewriting the order. And the last one would be go back to that third variation or that third expression and let's get 1 by itself. And so the last variation on that is subtracting cotangent. So we'll have cosecant squared x minus 1. All right, so let's put a box around that. All right, so we've covered now 3 Pythagorean identities, each of which has 2 variations. So if you were adding them all up, what's the total number that we have? 9. Okay, there's 1 plus its 2 variations, and then there's number 2 plus its 2 variations, and there's number 3 plus its 2 variations, so there's 9 of them. That's the end of identities. Okay, yeah. Whoops! You're right, I wrote it wrong, didn't I? Thank you for catching that. Cotangent squared, thank you. I wouldn't want to give you the wrong thing like I did yesterday. Okay, so we're done. Yesterday we learned 4 main trig identities, 6 reflection identities, 6 shift identities. So yesterday was a total 6, 6, and 4, okay, a total of 16. So today should be easy. We're only learning 9. And we're really only learning, truthfully, you only have to know 1. Because from the 1, you can make all the rest. Some teachers will just give you a list of them and say, memorize all of these 9. I would rather, I don't even care if you don't memorize them. Because I would rather you knew how to figure them out. So on a test or quiz, you know, okay, I memorized sine squared plus cosine squared equals 1. I'll memorize that one. But I could figure out the other ones with subtraction, and I could figure out the other ones with common denominators. If you know how to do that, then you've got all of them, and you didn't have to memorize them. You just have to know where they come from. Okay, now we're going to use those 9 things to replace and reduce. Okay, so keep these all handy, and we're going to work through some replace and reduce. All right, here we go. Cotangent squared x plus 1 over tangent squared x plus 1. So we want to look back. I don't expect you to have them memorized yet, but you just want to look back at the ones you put a box around and figure out what do I replace the top with and what can I replace the bottom with, and then I'll see if I can reduce. Okay, cotangent squared plus 1. Do you see that in any of the 3 boxes that we did? And if so, what could you replace it with? Go ahead. Okay, so you're seeing it right here. Now, does it matter that in the box it says 1 plus cotangent squared, but in the problem it says cotangent squared plus 1? In addition, it doesn't matter, okay, whether or not the order is the same. And so that would be our thing to replace. All right, so I'm going to use an equal sign to show I'm replacing, and I'm going to replace it with cosecant squared of x. Then I need tangent squared x plus 1. All right, so let me swipe up to the tangent section, and I've got tangent squared x plus 1 right here, and that can be replaced with secant squared x. So I'll come here and I'll replace with secant squared x. Okay, so I did some replacing. I'm not ready to reduce yet though. I have some more replacing to do. So a couple things. I would probably replace this fraction bar here with the division sign. So I'm going to put an equal sign, and I'm going to say, all right, I have cosecant squared x divided by secant squared. So that would be the replacing I would do. And then I would replace, I'm not ready to reduce still, I'd replace these things with the main ones that we learned yesterday. So cosecant, I know, is 1 over sine, and I still have a square with an x after it, and divided by. And secant, I know, is 1 over cosine squared x. I still have more replacing to do because I can't reduce yet because the 1's are in the wrong place. And so my last replacing I'll do is to replace this division sign again and flip the reciprocal of that second equation. So I'll have 1 over the sine of x, sine squared of x, now times the cosine squared of x over 1. And now I'm to the point where I could reduce. And the 1's will reduce away, leaving me with an equal sign of cosine squared with an x after it, and sine squared with an x after it. And the final simplification is that anytime cosine squared is on the top and sine squared is on the bottom, that would be equal to cotangent squared of x. And that is now in its most simple form compared to how the problem started. So a lot of this is similar to what you were doing last night. We just have a few more identities to work with that will help us simplify. Okay, does anybody have a question on that one? Okay, let's try another one. Okay, let's try 1 minus sine squared over cosecant squared of x minus 1. So we'll kind of do the same thing, sort of scroll to the section. So the top one is going to come from identity number 1 because it's got sine squared. So I'll scroll up a little bit, swipe up, and look at, okay, I want this one this time, 1 minus sine squared. And 1 minus sine squared is replaceable on the other side with cosine squared. So I'll come back down so I can replace this with cosine squared x. The next one is cosecant squared of x minus 1. So that's going to come from this third version of the identity. So cosecant squared of x minus 1, I see that right here. And I see that that's replaceable with cotangent squared. And so I'll replace that with cotangent squared. And now you'll notice that this problem has a lot of similarities to the one we just did. We should replace the division fraction bar and turn it into a cosine squared x divided by cotangent squared x. Then we should replace cotangent squared. We don't replace cosine squared. So cotangent squared divided by, then we replace cosine squared divided by, replace that with cosine squared of x over sine of x squared of x. I can't reduce yet because the cosines are in the wrong spot. They're both in the numerator. So then I replace my division with multiply by the reciprocal. So cos squared multiplied by, and then I'll flip sine squared over cos squared. So finally I've done enough replacing where I'm to the point where I can reduce. So I did replace, 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 and now finally reduce, and I'm left with the simple answer of sine squared of x. Okay, how are we doing? Okay? All right, let's try something different that doesn't look like that. Try and show you one of everything from your homework. All right, cosecant squared negative x minus cos squared negative x secant squared negative x. Okay, so these are using what kind of identities from yesterday? Since it's got all the negatives in it. What were those called?
Reflections.
Reflections, okay. And so now that we fixed your notes and we've got your reflection ones right, which one of these automatically switches to positive? Cosine and secant. So those two that are next to each other. So these two right here, that one and that one, because they're in cosine and secant, are automatically going to switch to positive. So we'll switch those both to, let's put an equal sign here, and I'm going to switch both of those to positive. But there's still the subtraction in front. It doesn't change the subtraction, it just changed the ones that were inside. Okay, bless you. All right, what do I do with cosecant squared? What does it do? Okay, well that negative goes to the front, but it has a square on it. So how many negatives actually go to the front? 2. Because cosecant squared means this is really cosecant negative x next to another cosecant negative x. There's 2 of them next to each other, that's what square means. And so both of the negatives go to the front. And what happens when a double negative goes to the front? You end up with a positive. So we are ending up with a positive here. All right, so we did the replacing on the negatives. Now let's do a replacing of something else. And this secant squared right here, I'm going to replace with the main simple identity of 1 over cosine. So I'm going to keep all the rest of the stuff the same, but I'm going to replace secant with 1 over cosine. And that is enough replacing for me to be able to do a little reducing. Since I replaced secant with 1 over cosine, I now notice that the cosine squareds will reduce away, leaving me with cosecant squared of x minus 1. And that's not quite as simple as it can go, because this now is a Pythagorean identity. Cosecant squared minus 1, scroll up to the third one, and we see cosecant squared minus 1, it has an arrow by it already, can be replaced with cotangent squared. And so in this question, this third example, I can replace that equals cotangent squared, and that's in its most simple form. Okay, any questions on that one? Okay, we just keep going. There's so many different variations of these. I really would like to show you as many as I can so that you are more familiar with them when your homework comes. All right, how about this one? How about secant squared x plus cotangent squared x in parentheses minus, and then in parentheses after that, tan squared x plus cosecant squared x. All right, so 2 parentheses with a negative in between. what's my first step? 2 parentheses with a negative in between. What do I do there? How do I get this problem going? Yes, I distribute the negative. Anything with parentheses is going to have some distributing to do. And so we're going to take this negative and we're going to distribute it. All right, so things you can distribute. You can distribute negatives. You can distribute numbers. Things you can't distribute, the word sine, the word cosine, the word tangent. You can't distribute that. That requires the cheer that we learned right before spring break. So things you can distribute, negatives and positives, and numbers, and even variables, but you can't distribute the word sine, the word cosine. All right, so this becomes, after I distribute, secant squared x plus cotangent squared x minus tangent squared x minus cosecant squared x. So I just distributed. Now this is sort of a jumbled mess. The order is not good right now. So look back at those things we put the boxes around. In terms of grouping things together, there's only an identity when tangent is paired with secant squared. Tangent squared and secant squared. Or there's only an identity when cotangent is paired with cosecant squared. Remember, the cos have to go together. Cotangent with cosecant. And then tangent goes with secant. So the order I have right now is not the order I want, because I want the parts of co together. And so what I'm going to do is switch the order so that I've got them. I would really like secant x. I'd like what comes next to be the minus tangent, because those two are part of the same identity. And then I'd like the plus cotangent to go next, and then the minus cosecant. So I'd really like it's totally legal to do, as long as you keep the tangent negative and keep the cotangent positive. Okay, now I'm ready to do some replacing. These two, secant x squared, or secant squared x minus tangent squared x, if I scroll back up, and so maybe you're going to want to have these on a separate piece of paper or something, but if I look back up here, here's right here. Secant squared x minus tangent squared x. In that order, paired together, what are they replaced with? The number 1. And then the other one is right here. Cosecant squared x minus cotangent squared x. All right, so let's take a look. Secant squared x minus tangent squared x. That is replaceable with the number 1. All right, what about the next set? Cotangent squared x minus cosecant squared x. Let's just double check that. What do you mean? It's not the same. The order in my problem is cotangent squared minus cosecant squared. The order in here is backwards. Does subtraction order matter? Yeah. Okay. So what's your hypothesis? If the order cosecant squared x minus cotangent squared x would be equal to 1, what would it be if the order was switched around? Negative 1. I mean, that's how subtraction works, right? 5 minus 4 is 1. Switch the order. 4 minus 5, not 1 anymore. Negative 1. And so I do have to be careful about the order here. And so I'm going to replace this last thing with negative 1. And look what I end up with. My answer is 0 after all that. Okay, this whole thing simplified down to 0. Okay, one more and then we can be finished. Okay. So you can see why with your open quiz, why I'm going to let you use your notes, right? Because it's nice to be able to look back at all of these. Okay, last one. Oops. Cosecant without a square, x plus 1, and cosecant without a square, minus 1. So parentheses again. Last time we had parentheses that had a subtraction in between them. This time there's nothing between them. So what do I do with this? I FOIL. Okay, this is a FOIL opportunity. First, outside, inside, past. All right, so first, cosecant to cosecant. That makes cosecant squared with an x after it. Outside, cosecant to minus 1. That gives me minus cosecant x. Inside, 1 to cosecant x. That gives me positive cosecant x. And then last, 1 to negative 1 gives me minus 1. Hey, what do you notice happens? Cosecant squared x minus cosecant x plus cosecant x minus 1. They cancel out. These two cancel out because one's a minus and one's a plus. So then what am I left with? Cosecant squared x minus 1. And then you should be going ding, 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 cosecant squared x minus 1. I know that. Maybe you don't have it memorized yet, but you know that it's there. So we look back. Cosecant squared x minus 1. Yep, we see that again right here for the second time. And that is going to be replaceable with then cotangent squared of x.